Okay, welcome back. So, in the plane you have O and a bunch of PIs, and um, what the heck is? Okay, I'm assuming alpha is fixed, right? So, okay, you fix some alpha between 0 and 1, and the points have the property that the nth point is distance at least. Um, what the heck is this? All right, OPN is at least there's some distance, and you want to say like, um, how fast does? Oh gosh. Uh, how fast does Rn have to grow? So, do I have to use the law of cosines? I think I have to use the law of cosines. Um, hmm. I probably have to use the law of cosines. All right, fine. I guess like the sentiment is that like eventually it comes like if you know OPI and OPHA, the only thing you don't know is the angle, right? That's nothing. And so the idea is that bigger angles will make it farther, and by like some form of the pigeonhole principle, you can. I'm not going to make these precise quite yet, but like, if you have a lot of points, eventually you will have two that are pretty close in angle. Like if you, okay, I'll be concrete. If you have 360, if you take any 360 points by pigeonhole principle, two of them will be within 1 degree of each other. So we are told that, let's say I is less than j, ri squared plus rj squared minus 2ri rj. This is what the law of cosine says, right? Let's say epsilon is less than or equal to like 2 pi over n, some large capital N. So this is the distance between them, and we're told that this is also at least whatever the smaller number is to the alpha power. Okay, that's fine. Then what happens is we think like the right hand side is pretty small because n is big, so that cosine will be close to 1. How do I formalize this? Let's just use Taylor series. Ri squared plus rj squared minus. Okay, so anyone know what the Taylor series of cosine is? It's like actually, honestly, at this point I should type this because these are like just long equations. So ri to the alpha. Well, yeah, we'll save the board space for stuff that requires actually drawing things. Is less than or equal to ri squared plus rj squared minus 2ri rj cos 2 pi over n is what I said. So when I take the Taylor series for cosine up to some error, this is going to be like ri minus rj all squared plus, okay, so x squared over 2 ri rj times pi over n. So it's like 2 pi over n all squared plus some crap that is O of n to the minus 4. Okay, and the question is like, how fast does that force Ri's to grow? So I should be able to do this for like large I, like there can, for each n, for any large n, there exists I and j with I, let's say I less than j less than I plus n, capital N. Let me make sure I got the quantifiers right. Let's say n is greater than like 3. I don't really want to deal with n equals 2. Then it's just stupid. But yeah. This inequality might be non-strict. I don't think it really matters. Fuck. I feel like I don't know how big this makes it grow. Like, because the thing is, like, the R stuff is on both sides. So, oh, sorry, you're right. Ri to the 2 alpha. Oh, Ri to the alpha. Because the law of cosine squares everything. Yeah, like, I don't know how fast this makes it grow. Can we assume Ri is increasing? No. I mean, it probably is, but I don't know how to prove it. Well, it depends on what you mean, probably. Like, it's probably the case that, like, in the cases that are closest to equality / most interesting / whatever, then you think the Ris are increasing. But I don't see a way to, like, assume it easily. I think. Wait, actually, which way is it going? Wait, hang on. What am I trying to show? I'm trying to show that the Ris grow kind of fast, right? Yeah, I want a lower bound. I want to lower bound the RIs somehow. I don't know exactly how. I mean, okay. I guess in principle what I could do is I could plug in like what it tells me and see like what, like if I assumed Rn was equal to Cn to the beta and like see what it tells me, it'll probably be approximately the correct value of beta, just so I know what the value of beta is. Seems really I think I've used up all the geometry though. Like the reason I feel like all the geo is used up by this calculation here is because like when the angle is bigger, when the angle is like bounded away from 0, it's not close anymore. Moreover, you can kind of like imagine the angle of the PIs is roughly in an arithmetic progression. Actually, if that's true, hang on, no, something's wrong. J is around I plus 1-ish. Actually, not. If you make the angles an arithmetic progression, you can get a construction. I think that will do something reasonable. And this I guess the sentiment is that like I'm gonna change letters. Sorry, I actually hate these letters now. The reason I hate these letters is because you pick capital N first, and then you pick the indices. So this is giving me the wrong instincts. I think what I want to say is for any k, I pick a constant k, and then I can find an index, and I'm gonna call the bottom index n, and like the other one we can call it n prime. All right, we'll just call it n prime. Update and it's like, even though I said k is big, relative to k, n is actually bigger than k by a lot. So the idea is that like n and n prime isn't very different from n and n plus 1. And indeed, in the equality case, I think... Well, actually no. Depending on how you do the arithmetic progression, I guess. Okay, I don't know what's going on anymore. And okay, we'll call it m, all right, so that I don't have to keep typing apostrophes. So like m is slightly bigger than m, but not by much. What prevents ri's all equal to 0? Nothing. I think it's like the way the quantifiers work. It's like you want a... The problem's a little clumsily worded. I think it's like fix alpha, find a beta such that for every sequence... Wait, hang on. Actually, that's bad. Guys, I think we can take capital C equals 0 and any beta works. Yay! That's probably not what was meant. Let me see what the original statement said. Oh, there's no solution. Okay, I'm going to assume that the problem wants capital C greater than 0. The statement holds for any PIs satisfying... Wait, actually, yeah, hang on. Something's actually wrong. You're right. Even if I patch it that way, if all the RIs are 0... Can we assume RI is not 0? Does that fix the issue? You don't have to solve the problems. You're here. You just have to outsmart them. Wait, okay. I need to think what the problem wants. So if we... different from O. We're going to assume the PIs are different from O, because otherwise I think the problem is probably stupid. Yeah, because otherwise, yeah, they just have to be different from O. No. If all the RIs are 0, then no, yeah, it's bad. It's real bad. Okay, I'm confused now. So I think if you assume the distances are, if Ri is bigger than 0, I think the issues go away. Because then the hypothesis that the points are not too close to each other actually means like something. And then you want that to make the points go... There should be a beta for which the statement is true. Like in particular, beta equals 0 should work, I think, because is that? Yeah, the points can't all be within. Wait, no, that's not. Hang on. No, I'm confused. What the heck? I feel like I'm worried that beta equals 0 isn't even true. Like, because this is for all n. So what prevents a sequence from being mostly well-behaved, and then every so often you have an element that's really close to the origin? I don't think there's anything that prevents that, right? Hang on, something's wrong. Um, yeah, I know it's per sequence. Yeah, that I don't think that. Again, hang on, I'm confused. There's too many quantifiers. Help. Such that for some constant C independent of n, but depending on the PIs. Maybe? I feel like that's so bad though, if you have to assume... It would... Okay, actually the problem would still be interesting if the RI are increasing. But let me give my counterexample if the RI are not increasing. Just so that I'm not deluding myself into thinking something's wrong when it's not. We're gonna take pi equals 2 to the I, comma 0 for most I. And like alpha is like, I don't know, 1 over 1,000 or something. It doesn't really matter. And then what I'm going to do is like, we're going to take like c equals 1. That's also okay. Oh, actually it doesn't matter what constant I take. Sorry. Beta equals 0. Like basically what I'm going to do is like, for almost all I, it's like you put the points somewhere far away where they won't cause trouble. And then every so often, like, unless I is like, I don't know where to put them, okay? Hang on, I'm really confused. For some constant C. So if I have a sequence of RIs that approaches the center, does that kill something? Fuck. There's too many quantifiers. Beta equals 0 is true. So in order for there to not exist a constant C, that means I have like a sequence that like approaches 0. Yeah, a sequence that approaches 0. So I have like a sequence of PIs, and in that case the indices don't matter. So it's like you get a bunch of points that are close. Then what I can do is I can look at this thing and say, okay, I mean, this is something small. This is something even smaller. Yeah. Help, I'm so confused. Ah. Because I feel like if the RIs aren't increasing, right, then you can take a valid sequence and then like shift the indices, right? Something's wrong. Who suggested this? Or like, is there a way I can check this? Because I'm concerned right now that like, if PI is a valid sequence, then I can permute it however I want. So I can take this sequence here and then like do some permutation. And that will show that when beta is greater than 0, you always die. Because if you pick a beta and a constant, then, I mean, it just doesn't work, right? Like if I have a beta and a C, I can pick an n such that Cn to the beta is like bigger than whatever yeah. Yeah, something's very wrong. And then it fails. Oh, no. Wait, hang on. No, the C can depend on the PIs. Oh, I'm so confused. Oh no, give me a moment. I hate quantifiers. Yeah, the order doesn't matter except for that. That's just so strange. Because it's like, it means that if I take this like 2 to the I sequence, that obviously works as like a straw man. I can make 1 and 2. I feel like something's really wrong. Yeah, beta equals 0 is probably fine. That part I'm not worried about. I'm worried about this part about like beta greater than 0, where that bound grows on some parameter that seems like it doesn't matter or something, right? So if anyone wants to confirm that the RIs are like not increasing or something, that would be good. Because I want to try to write something down now, alright? I want to write down a sequence of points defined by I don't need the law of cosines part here. I don't. I'm gonna erase this whole part too, actually. I want to say like P of 2 to the I is 2 to the I comma 0. And then P of like n is like fills in the gaps whenever for all n not equal to a power of 2. Like, so 2 to the whatever. So it doesn't really matter what the order is. Sorry, let me not use 2 here. I'm gonna use like 2 to the 2 to the I, alright? So it's sort of like I take like shit. No. I need to leave some gaps, right? Do I actually? I need to leave some gaps. Alright, fine. Here, you can have a token like 10i or something. I don't fucking know. And then where ANs are like integers not divisible by 10 or something. I don't know. It doesn't really matter. The point is that like if you permute the RIs however the fuck you want, then you're going to run into problems because I can like the set of points at the set of points of the form like 2 to the x comma 0 is going to be a valid construction for it is just a valid construction, right? Like the set of points which are powers of 2 will work for any alpha strictly less than 1. And in fact for alpha equals 1 for that matter. Because the distance between any powers of 2 is at least the smaller power of 2. And then you're like, well, they didn't give me any condition on the indices, so I'm just going to put, you know, I'm going to make one subsequence of like really antagonistic indices where, you know, like the distance is just much smaller than the index to make sure that no positive beta value of beta will possibly satisfy the conclusion. So like trollolol, right? And then, you know, the other points, they can be whatever they want. Just use any distinct integers. And then now there is no constant c and beta for which 2 to the 10 to the I will exceed, you know, 2 to the 2 to the I or whatever it is, to the beta, for any beta greater than 0. On the other hand, if beta is equal to 0, then all this is saying is that you need the sequence to eventually leave. You need to show that there's no sequence that converges to O, which should be doable with the law of cosines crap that I wrote down. Because now there's no dependence on the indices for the conclusion either, which is actually what we want. Right? Okay, so why is there no sequence that converges to O? So that would mean that I can get, you know, numbers in this equation which are as small as I want. That seems implausible because this thing takes some large k, takes some epsilon. Yeah, there's just no way. You take k big enough such that like it wipes this junk out. This thing will be at most epsilon squared-ish, right? And this is like epsilon to the 2 alpha, and alpha is less than 1. And then you pick k big enough that like... This is, yeah. There's no way. In fact, I think you can take like k equals like 6, right? Because the point is like if the points are close to like... Hang on. Is this homogeneous? It's not. Like I feel like you take capital C equals 1 and you say, I claim that there are points outside the unit. There are like... Or not... Okay. I claim there are at most finitely many points inside the unit circle. Because if there's more than 6, then like you have a triangle with some angle less than 60 degrees. But like for points when you're strictly inside the unit circle, you know, you have a tiny angle and raising to the alpha power makes the... Okay, so I think this is a complete solution to the problem as written, but also the problem as written feels idiotic. Can like anyone confirm whether this is actually in the intended problem statement? I can't find it. Okay, well that's a bummer. I'm gonna look for it then. I feel like this problem would be much more interesting if the RIs were required to be increasing, in which case maybe like something's actually happening. But as written, this seems like... Actually, you know what? Yeah, give me a moment. I bring you all the brick. Let's see if it's in here. There's actually only a shortlisted problems actually, so it might not even be in here. Yeah, this... No, it has long listed. Page 41. SWE-5. Sweden. So... Nope, it's increasing. So if you look at the version that's printed in the IMO compendium, it says R1 at least, or at most R2. Here. I don't know if this is legible actually. But you can see it says R, RI are increasing. But the real kicker is that in the corrected statement where it says the RI are increasing, there's a footnote, and let me read the footnote to you, alright? This problem is not elementary. The solution offered by the proposer, which is not quite clear and complete, only shows that if such a beta exists, then beta is at least 1 over 2 times 1 minus alpha. So, the wrong problem statement is idiotic, although doable. And the corrected problem statement appears to not be solved, is what I'm gathering. Like, not only is it not solved, like, not only was the solution wrong, like, it only solved half the problem, but according to this, like, the solution wasn't elementary either. Yeah, yeah, what you said. Beta is greater than 1 all over 2 minus 2 alpha. So, yes, what you wrote. I wonder what the... Okay. Cool. We're gonna put a community warning. I don't know, okay. Yeah, I mean, it doesn't tell me exactly. It just says if beta exists, that inequality is true, and I'm not sure what that is supposed to mean. I agree that it seems like it should just be like an example of a construction. The textbook has, so the book has written the condition, the extra condition, R1 less than R2 less than R3. This makes sense because without it, it also has a footnote that says, oh shit, I shouldn't have closed the book because now I need the footnote. Yeah.